Alright guys, so today, for this week, we're doing polar coordinates. Polar coordinates, basically, we use them a lot when we're talking about like navigation, physics. Engineers use them to deal with like, something that's like a hemisphere or a globe or a dome. It just makes calculating stuff a little easier because now you're not dealing with rectangles. So you're dealing with circles, and we deal with a lot of circles in the real world. So you see it come up a lot in especially like airplane travel and things like that because the Earth is circular. So that's why you use it. So this is just saying that rectangular coordinates. Here's the origin 0, 0. You use the x and y axis, and where your p is x comma y, your point. Okay, and then you guys know this. X is the horizontal distance, y is the vertical distance. Now with polar coordinates, we talk about the pole. So the origin is now the pole, the center of the graph. The polar axis, that's the positive x-axis, and your p instead of x comma y is now r comma theta. So a little different. R is the distance from the pole, so your radius. And theta is the angle in standard position which the terminal side through P. So think of the unit circle. That's what we're talking about with here. Okay? It's not too bad. When you see the graph here, you'll get it. It'll make sense. So this is a polar graph. Okay? So again, we're no longer talking about x comma y. We're talking about the pole, the angle, and then the radius distance. Okay? So, these are just polar points. So A would be what? Well, it would be a distance of 1, because this circle is, or 2, sorry, this circle is 2. This circle is 3, 4. So it's just different circles with different radiuses, okay? And your point is on the circle of radius 2 at an angle of pi over 4. So 2 and pi over 4, okay? So that's how this polar coordinate stuff works, okay? You can also go the other way. Remember, on the unit circle, positive angles went this way, negative angles went this way. You can define it as a positive or a negative angle. So, in polar coordinates, points do not have a unique representation. For instance, the point r theta can be represented as r of theta plus or minus 2 pi. And if you remember back to the unit circle, 2 pi was just a whole trip around the circle. So, if I've got my polar coordinate system, okay, and I have this point right here on the unit circle radius 1. Okay? And we'll say this is pi over 4. Well, it's from here to here, right? That's pi over 4. Well, it can also be from here all the way around and then back to here. So that would be plus 1 trip around the circle. That's what that's talking about. Okay? Find 4 other polar representations of the point 4 comma pi over 6. Well, 4 and pi over 6 plus 2 pi. 4 and pi over 6 minus 2 pi. 4 and pi over 6 plus 4 pi. I mean, there's an infinite possibilities. You can just keep changing this number and add 2 more pi to it. And you just keep getting more. Okay? Does that make sense? Alright, so convert between polar and rectangular coordinates. So this is where things get a little dicey. Let me pull this up. So we've got, this is the formulas. So we have these formulas because we have a point right here in rectangular coordinates, x comma y. So, get my rag. So we can agree that this point is x, y. That's, you guys have been doing that since algebra 1. Okay? So, what we need to do now is find a way to say what that point is in polar coordinates r theta. Okay? So what we're going to do is, we know that this angle is theta, and this length is r. Okay? So how can we find r? Well, what did that ancient mathematician named Pythagoras say? Well, he said that x squared plus y squared is the hypotenuse, or r squared. So then if you just take the square root away, the square root of x squared plus y squared is r. Okay? So that's easy. We can do that. Alright? And so now you need to have a way to define x and y in terms of r, and that's where this r cosine theta is x and r sine theta is y comes in. Because what happens is, if you look at this triangle, well, what's the cosine of theta? It's x over r. So cosine of theta is x over r. And what's the sine of theta? Well, it's y over r. So sine theta, y over r. And then you just do the algebra, and you move this r over here on both sides. You get r cosine theta equals x, and r sine theta equals y. Okay, so that's your conversion rate to do the math, to convert between the two. So let's look at an example. Let me move this up. So we said convert to rectangular coordinates. So we have r is -8 and theta is 5 pi over 3. Okay? So what we need to do is we need to utilize these guys right here. Okay? R cosine theta. So -8 cosine 5 pi over 3. That's your x. Okay? And then you do the same thing, but with for the y, it's sine. So -8 sine 5 pi over 3. That's your y. And then if you look back at the unit circle, the cosine of 5 pi over 3 is -√3 over 2. So you get -√3 over 2 and whatchamacallit? 1/2, I think, for sine. Yeah, 1/2. So this one right here is just going to be -8 times 1/2. And this one's going to be -8 times -√3 over 2. And so you end up with, for your x, you get negative, so negative is 8 √3 over 2. And this one you get -4. Okay? And the reason you get 4 √3 here is because 8 divided by 2 is 4. So there's your point. Okay? Pretty simple. Not too bad. Again, this goes back to the unit circle. So let's look at this other one. 2 and theta is, what is it, 3 pi over 2? Okay, so same thing. R sine theta and R cosine theta. So x is 2 cosine 3 pi over 2. And y is 2 sine 3 pi over 2. Okay, so the cosine of 3 pi over 2 is 0. I remember right, yeah. And the sine of 3 pi over 2 is -1, so you get 2 times -1, which is -2. So then your point is 0, -2. Okay. So guys, this isn't too bad. All right? You guys can do this just by doing a little bit of the trig stuff. Okay? I warned y'all at the beginning of the year, or the beginning of the semester. Trig was going to be around till the end of the semester. It wasn't going anywhere. Okay? So let's look at this last one. And this last one, you are going to need to use some kind of calculator that can do trig. Make sure you are in radians when you do this. So R is 6 and theta is 3.8. So then X is 6 cosine 3.8 and Y is 6 sine 3.8. And then you just plug that in the calculator and you get X and Y. All right, any questions? See me in tutorials.